Hey guys, welcome back to another Leetcode problem solving tutorial. And in this tutorial I'm going to be showing you guys how we can solve question number 2, asking us to add two numbers, and the numbers are given in the form of a linked list. Okay, so after reading this question you should be able to see that it's basically asking us to compute what, so let's look at this example here. This is basically asking us to compute what 342, let me just write the numbers a bit more spaced, 342 plus 465 is, because remember these linked lists are basically the digits of the number in reverse, and then we want to return the answer also as a reverse linked list. So 342 plus 465, how do we do this? Well, we'd first, if we were doing this as column addition, we'd first find out what this plus this is, 7, nothing to carry. Then we find what 4 plus 6 is, and that's 0, so we carry the 1. And then we execute this sum over here, which is going to be 8. So all in all, our result is 8, which you can 807, which you can see over here, and its return is 708 to represent the the linked list in reverse. Okay, so how are we going to implement this using linked lists? Well, you should be able to notice that what we just did was add the units digits first, then the seconds units, the tens digits, then the hundreds, and we want that order, and that's essentially what reversing it does for us, because now we're able to access units digits first, then the tens digits, and then the hundreds digits. So what I'll do is I'll write out this like you get in the question. So we have a linked list 2, 4, 3, as well as 5, 6, 4. And the idea is, like in column addition, we execute from the right. In this addition of linked lists, the lists have already been reversed for us, so we don't actually have to execute from the right anymore. We can execute from the left and then sort of work the other way. So this is going to be 7, 0, 1, 8. And you can see this also makes sure that the answer is reversed for us before we even have to do anything. So we don't actually have to reverse this linked list ourselves. So hopefully you guys can see this is fairly easy. We just have to keep track of a carry variable. So initialize this as 0 at the start, and then it's just going to be, well, 1 if this number is greater than 9, and otherwise it's just going to be 0. So we carry on 0 there, add these three together, we get 10, which is greater than 9, so then we put this units digit here and carry the 1, and then execute this sum to get 8. And yeah, that's the idea. Now, one thing we have to be careful of is, let's say this number was, let's say this number was 5 instead, okay? So now what's going to happen is when we execute this sum here, we're going to end up getting a 0, and we'd effectively have to carry the 1, but there's nowhere to carry it. So this is essentially the same as if we were computing 542 plus 465, and we'd get 7, 1, and then we'd get an extra digit at the end for the 1000. So that's essentially what's happening here. We get a extra digit 0, we carry the 1, and this just becomes 1007, which is the correct answer. So yeah, that's the basic idea on how we're going to solve this. We're simply just going to execute this as if this was column addition, and yeah, implement that function. So let's get coding. Okay, so first thing we're going to do is just initialize our conditions. So we're going to need a variable called carry, and this is essentially storing the carry item, the digit which is being carried. And it starts off as 0, nice and easily. And then what we're going to do is we're going to have a result, and this is just going to be a list node which stores our answers. We need to actually kind of store it in the form of a list. So for now I'll just have it as starting off with 0 and then null, and what we'll do is we'll use a result pointer to actually modify this so that we can just return result nice and easily. Initialize this as result, and To add items to this result thing, what we can do is we can do result pointer.next is equal to, and then add whatever we want, and then we just need to increment result pointer to now point to this node. So we add the node into here, then increment into it, if that makes sense. Like that, nice and easily. So that's how we're going to add digits, and now we can get started on our while loop. So our while loop is going to continue while both list1 and list2 are, while either list1 or list2 still has digits remaining in it. So this is going to be while list1 is not equal to none, which means, null, which implies that there's still items remaining in list1, or if list2 is not equal to null, since this would imply list2 has items remaining in it. And then we need to get our two numbers which are going to add together, which is basically the units digits, or the digits we're currently on. So this is pretty simple. Num1 is going to be, well, it's either going to be list1.val, if that exists, so we need to have some sort of condition. So we'll do list1 is equal to, not equal to null. Then in this case, we're going to set it equal to list1.val. Otherwise, we're just going to set it equal to 0. And this is essentially happening if, let's say, this list extended past go on to there. And now when we're on this column, list2 doesn't have anything in it, so we're just going to assign a quick 0 there, just so there's no complications when we add our sum. So we'll do the same thing for list2 to get the digit for list2, like so. And then we can actually execute our, what I'll call the column sum. It's just going to be num1 plus num2 plus carry. And I'm going to make this a let. Okay. So now we need to, column sum is this number here, but if this number is greater than 9, if column sum is greater than 9, then we actually need to assign 1 to carry, and then reduce column sum by 10, just so we can bring this number down to a number between 0 and 9, so it only takes up 1 unit. So for example, if this number was 10 over here, or 11, or 12, so column sum is greater than 9, so set carry to 1 and then set column sum, take away 10, so this number now just becomes 2 here, and then we carry to 1, just like you would in normal column addition. Otherwise we just set carry equal to 0. Like so. So that's nice and easy. Now the final thing to do is, well, we've got our column sum, we just need to add this to the result, so we'll do result pointer dot next is equal to new list node, column sum, and keep that equal to null, and then increment result pointer to basically go to the next item, result pointer dot next, like so. That's nice and easy. And then the final thing to do is actually increment list1 and list2, because these are pointers to the current item in the list. So it's going to start off here, then we want list1 to go to this and list2 to go to this, and this is pretty similar to just incrementing it, except for the fact that there's a possibility there might not be any items. So again, we need a conditional thing. We only want to increment either list if there are items remaining in it, so we can do L1 is equal to, we'll check if it's not equal to null, and if this is true, then we set it equal to L1.next, and otherwise we just leave it as L1, leave it in the same position it is, and do the same thing for L2. Nice and easy, just incrementing the lists. Okay, so now the final step is to add our carry, because there's a chance that this carry might have overflowed past the any items here, and then what we need to do is just add it in at the end. So we can do if carry is greater than 0, well that means we need to add it to our result, so we'll just do the same thing as we did here. Result pointer.next is equal to carrying it, and then we don't have to really increment result pointer, but we can if we want. It doesn't actually matter. All that matters is that we add this to result pointer, and then finally we can just return result.next. So result pointer has been affecting result this whole time, so we've been adding all our numbers just like that, and then we want to get rid of this initial 0 we added at the start, because the only reason we added that was so we could access properties of a list node item, list node object such as next, because we can't just initialize this as null. That's not going to let you use any next property like so. So that's why we initialize it with 0 and then null, and then we just return result.next to get rid of that head. So yeah, this is the basic idea of this problem. It seems complicated, but it's actually pretty simple. It's just implementing a column addition algorithm. And yeah, let's put this into Leetcode and see what we get. Okay, so get a decent result, not the best, but of course this is actually pretty optimal because this is just going to go through each loop, each list at the same time. So this has an O of n time complexity as well as O of n space complexity, and yeah, pretty average on the bell curve. Let's just see over here. Right, okay. Yeah, so there's other methods, but overall this is pretty average method. How you solve question number 2. Thanks for watching, and I'll see you guys in a future tutorial. Bye!